All right, let's get started here with some congruent triangles. Now, if two triangles are congruent, okay, that means they have the same angles and sides. Those are like the parts of the triangle, angles and sides. So if two triangles are congruent, this means that all corresponding parts, so if you have two triangles, they're matching angles, they're matching sides, or the ones that correspond to each other, which are, the angles and sides. Those corresponding parts, the angles and sides, are congruent to each other. So here you have these two triangles. Okay, now this is called a congruency statement, is what we have here, where you write down that one triangle is congruent to another triangle. So we can zoom in. Okay, so these two triangles, and it's important how they're written so that the parts match up. So if this is written triangle ABC, and if angle A is to match with angle D, because you can note how these two triangles are marked. The angle A is congruent to angle D, C with 3 marks, let's see, F, and B with E. Then this side, BC with FE, AB with DE, and so on. So you notice how the first triangle is written determines how the second triangle is written in this statement, in your congruency statement. So this is called a congruency statement. So if the first triangle is written triangle ABC, then the next triangle has to be written so that it matches up. That would have to be DEF. And if you look over here at the actual statement, you see you have triangle ABC. Well, angle A would match with angle D because those are first, angle B with angle E because they're second, and angle C with angle F. And the same thing with the sides. Like if you go AB, that has to match with DE. And if you look at the statement, A to B, D to E. So the next, like BC would match with EF. So go to BC and EF. Yeah, it does. Okay. And then the last one, A to C. So A to C with D to F. Okay, so that's how it's written, and that's how it needs to be in order for it to be a true, valid congruency statement. All right? All right, let's see. Down to the next. These letters, CPC, So this means that after you have proven that two triangles are congruent, then their parts are congruent. So this, and the reason is this CPCTC, which stands for corresponding parts of congruent triangles are congruent. We'll write it down over here. So it stands for corresponding parts, that's sides and angles, right? If their sides and angles all match up, or if the two triangles are congruent, then all the sides and angles that match up are congruent to each other. So the corresponding parts of congruent triangles are congruent. Okay, corresponding parts of congruent triangles are congruent. So first, you have to know that the two triangles are proven to be congruent. Then you know that their parts are congruent. All right, let's see. Let's go to an example. Example 1 here. Let's see if we can zoomer. Zoom. All right, let's see. So it says list all the congruent angles and sides. So the triangle is JKL and PQR. So angles, so the first angle, angle J, would match with angle P. Next, angle K would match with or is congruent to the second one, angle Q. And angle L would be congruent to and correspond to angle R. Okay, there are the angles. So the sides then, looking at the statement JKL, so from J to K, so we'll say side JK would be congruent to side in the next one, be the first two, PQ. So without even drawing the triangle, we could name their congruent sides and angles. But you may want to, when we get further down the road here, when you have to match this up, is draw the triangles and make sure that the letters match, and then you can insert information. We'll get to that. So J to K, PQ, so let's go J to L. That would be congruent too. So if I went J to L, I'd have to go P to R. And then the last one from K to L, that would be congruent to, from K to L, Q to R. Okay, so write another valid congruency statement. So there's three. This would be one. So if we went a different direction, let's say we started with, instead of JKL, what if we went with triangle KLJ? That would be congruent to, well, if we wrote it KLJ, then we'd have to write the second one as QRP, so that the angles and sides matched up. And you could make, you could do more. You could say LKJ, so RQP, or LJK, RPQ. You could make up several congruency statements. It's just a matter of how you write the first one determines how you write the second one. All right, let's move over here. Example 2, what do we got? Let's pinch it down. Okay, example 2. All right, so we're given these two triangles, KPM, so from K to P to M, and AYC. All right, so we know that KP then would match up with AY, so let's just match them up, and then we can fill in all this information over here. PM would match with YC, and then the third side would have to match up. Okay, angle K matches with angle A. P would match with angle Y, and then M and C. Okay, so now we've marked up the triangles. Now we can go fill in this information over here. So what does KM match with? KM is congruent to AC, or you could just look at the statement. I guess you wouldn't even really need the figure. We could say, you could look at the way the letters are written. KM would match with AC. But a lot of times it's nice to have the figure. Let's see, PK, also PK going this way would be YA. Angle K, that matches with angle A. Triangle MPK, so it's just written differently. MPK, so ours would be CYA. Triangle CYA. Side CY, so going CY this way would have to be MP. Angle Y would have to be with angle P. Angle ACY, so ACY would be KMP. And triangle YAC, YAC would match with PKM, just written in the same order. Okay. So that's how we do the sides and angles given a congruency statement. Let's see, angle 3, or sorry, example 3. Da-da-da. Get that in there. All right. Okay, for example 3, we have triangle DEF and triangle JKL. So what I'm going to do is just draw two triangles. I don't know what shape or what these triangles look like. I'm just going to make it up. I'm just going to make them the same, kind of. And I'm going to label them in the right order. So if I go D, E, F, then I would have to go J, K, L. So I've just written them so that, you know, the sides and angles match up, and it looks, it's very easy to identify which angle goes with which and sides and so on. And I know, since it said the two triangles are congruent, that all their parts are congruent to each other. So that's how we're going to set up these equations. So triangle DEF and JKL. DEF, JKL. It says DE is 18, so I'll just write that in. And then visually in the end, we can see what's equal to what. EF is 23. DF is 9x minus 23. Let's see, what's next? JL is 7x minus 11. JK is 3y minus 21. And find x and y. Okay. So looking at the figures, now it's a little more clear that for 3y minus 21, that side matches with this side that's 18. So we could say 3y minus 21 equals 18. Those two. And then it's also clear that this side, DF, 9x minus 23, matches with and is equal to 7x minus 11. So we'll set those equal to each other. 9x minus 23 would equal 7x minus 11. So I have two different problems we're going to work out here. All right, so let's work out this x one here. So I'm going to subtract 7. So that would be 2x minus 23 equals negative 11. And then add 11. So 2x is going to equal, or sorry, not add 11, add 23. Add 23. Because I want the x, so add 23. 23 minus 11, that would be what, 12? And then divide by 2, so x would be 6. Okay? Then over here, let's see, I'll add 21. So 3y is going to equal 21 plus 18. So 21 and 10 is 31 plus 8 is 39. And then divide by 3. So y is going to equal 13. All right. So draw the triangles, fill in the information, and then you can see how you can set up the questions and solve. All right. Now, in proving, we have some different ways to prove triangles congruent. Okay? So we just learned the CP-CTC. That's after we've shown the triangles are congruent. Okay, so after one of these reasons, then we can say the parts are congruent. So let's learn about the different ways triangles are congruent. So if we look at the first rule, it says side, side, side. That means all the corresponding or the matching sides of one triangle are congruent to the same matching sides of another triangle. So like, you know, this one would match with this one, and let's say this one matched and is congruent to this one, and so on with this side. So you'd have 3 sides. So that means the two triangles are congruent by side, side, side. Okay, you have 3 pairs of congruent sides. For side, angle, side, yeah, 2 sides and an angle. The angle is in between the 2 sides. So that looks like something like this, like maybe an angle, or sorry, a side, maybe an angle, and a side. Something like that. Okay? Or the other way, you know, you could have had this angle, then you'd need this side. Okay, so that's the angle is in between the two sides. So that's side angle side. So if you can show that, you have an angle in between two sides, then the two triangles are congruent by side angle side. The next one, two angles in a side. The side is in between the two angles. So let's say you have an angle, another angle. Okay, if the side in between them is also congruent, then that's angle, side, angle. Okay, if that's what you have, then that's what it looks like, then it's angle, side, angle. And the other one, angle, angle, side, just means you have two angles and a side. So it could be any two angles, let's say this one and this one. Okay? So the side you would need would be one of the other two, these two over here. So maybe like, this one, or it could have been the other one. If it were this one in here, it would be angle, side, angle, if it would have been this side. But it's one of the other two sides. So two angles and a side. So, either this side was opposite this one or this one opposite this one. So it's just two angles and a side. Okay? This up here technically is angle, angle, side, but since the side is in between the two angles, we say angle, side, angle. So to prove any triangle, two triangles congruent, you need, for all of these, you're going to need an angle and a side somewhere. Okay, so whether it's in this combination, this combination, this combination, this one is just three sides, so this one doesn't need an angle, but this last one, hypotenuse leg. So this is when you have a right triangle, but it's not always when you have a right triangle. So it's not always, okay? So if it's a right triangle, you need the hypotenuse and another side in a right triangle only, okay? So if it's a right triangle and you see that the hypotenuse is congruent and some other side, then that's hypotenuse leg. Okay. If it's a right triangle and you have another angle and a side, then it might be angle, angle, side. Just because it's a right triangle does not mean it's always going to be hypotenuse leg. So that's what you need to remember. But yes, it would be the first thing to think about if you do have a right triangle is, oh, maybe it is hypotenuse leg. Okay. So if you notice we have an angle and two sides. Well, angle, side, side is not a rule, or side, side angle is not a rule, okay? We don't say angle, side, side. We don't want to swear, but that is not the rule, okay? If you have an angle and two sides, it has to be in the combination of side, angle, side, or angle, side, angle. It cannot be the side, side angle or angle, side, side, okay? Not a rule. Now, if that angle is a right angle, if it's a right angle, and one of the two sides is the hypotenuse, then it's hypotenuse leg. Okay, but it's not side, side angle, it's hypotenuse leg. All right, so make sure you understand what and when to use hypotenuse leg. All right, now, in proofs, if we are to find congruent sides, here's what would give you opportunity to find congruent sides. So if it were written down in the given, okay, these sides are congruent, given. If you have a midpoint, okay, if you have a midpoint, then you're going to have congruent sides, and that would be from the definition of being a midpoint. All right, so you have some segment or a side of a triangle or whatever, and there's a point in the middle, and it tells you that's a midpoint, then the two pieces, okay, are congruent, definition of midpoint. And one that's used a lot, if you have two triangles that are drawn and they share a side, okay, that's the reflexive property. So a side can be congruent to itself, and therefore it'd be congruent, it'd be the same side in both triangles, and we'll get to some of those here in a minute, but the reflexive property, okay, is also a way that you'd have a congruent side for triangles. Okay, now for angles, if they're given, and then the reasons that we've talked about, If you have vertical angles, those angles are congruent. Okay, you can say, oh, these two angles are congruent by vertical angles, and that allows us then, for the side that we needed, maybe to say side angle side or whatever. Now, if you have parallel lines, okay, now there's several ways to find congruent angles. They might be alternate interior or alternate exterior or corresponding. Okay, you'd have to see those angle pair relationships first, knowing that the lines are parallel. Then you have these angles congruent. Okay? And if you have an angle bisector, that's going to give you congruent angles. All right? So let's see what we got here. Page 8. So we're going to go through some of these figures, and then let's see, 8, and then you have some practice. So your assignment will kind of look like this. Let's see what we got here. Maybe we'll zoom in and go one by one. All right. All right, in this figure, it wants us to, A, are they congruent, yes or no? Yes or no. That's the first answer. And then we write the congruent statement if they are, and then what reason? Side, 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 side angle, side, whatever. Okay, so let's look at the figure. I'm looking at JMK and LKM. So I would choose those two triangles because I can see this angle is, in that triangle and in this triangle and this side. So I have a side and an angle. Well, if you notice in those two triangles, this side MK is the same in both. So that would be a reflexive property that MK is congruent to itself. So therefore, if we mark that, okay, on a proof you'd write it down, but here we're just noting it. If you mark that, because that's congruent to itself, you have to have a reason, then side angle side would be our rule. Okay, so let's say yes. And so we know that we'll say JMK, and then the other one would have to be then LKM, in that order. And the reason is side, angle, side. Okay. To the right. Same thing, looks like. We've got a right angle, so I'm thinking maybe hypotenuse leg, but I would need this side congruent to this side, and I don't know that I have that. I have this side though, so here's this side and this side, so it's marked. So I have a side, I have an angle. This side here is congruent to itself. Okay, it's in both triangles, so always look for that. If you see the figures drawn together, is shared sides. So this would be side angle side, not hypotenuse leg, because we don't have the hypotenuse. So this would be yes. Let's say triangle BCA. And then if I did B to C to A, I'd have to go CBD. And then our rule was side angle side. Okay, let's go next. Left to right. What do we got here? It says E is the midpoint. So if E is the midpoint, that means we have congruent segments. So if E is the midpoint of A to B, that means this side would be congruent to this side. Okay, because of the midpoint. It's also the midpoint of CD. So that means this side would be congruent to this side. What else can we look in the figure? Can we get the sides for side, side, side? Is there an angle somewhere we can figure out? I see vertical angles here. So this angle would be congruent to that angle. So then, side angle side would be our rule. So this would be yes. Let's name the triangle. Let's go AEC. or however you want to do it. Just make sure the second one matches up. So if it's AEC, then I have to go BED. And our rule was side angle side. Okay? All right, let's see. I can see I have a shared side, so that's the first thing I always look for, so I'll just mark that. And it looks like I have 3 sides now. All right, so this would be yes. So let's name our triangle, I don't know, ADC. So if it's ADC, then the next one would have to be CBA. So the parts match up. And then this would be side, side, side. We have 3 sides. All right, let's see what else. This one. What? Oh, parallel lines. I can see the markings for parallel lines. Okay, parallel. So if I have parallel lines, I'm going to look for maybe some, what kind of line. So if it might be easier just to kind of extend those a little bit just to look at them. I don't know. I kind of like it that way, but see what I can come up with. So parallel lines, this would be a transversal right here. I don't necessarily know where I can use any angles there. This would also be a transversal. And, oh, it looks like if these are my parallel lines, this angle and this angle would be corresponding. And that kind of fits with the sides that I already have. I have these 2 sides, so maybe I should have started looking in between those 2 sides to begin with. So now I have side angle side, because these are corresponding angles. Because I was given that these lines are parallel, I could say these 2 angles are congruent because of corresponding corresponding angles. So let's say yes then, because we've now have a reason for those to be congruent. And let's name it, if we go KLJ, if I write it in that order, then I would have to say MNL. And the reason is side angle side. SAS. Side angle side. All right, let's see here. Put that in the middle. All right, so let's see. I have parallel lines. Parallel lines. So alternate interior angles would be here and here. That's probably what I need, or here and here. Be alternate interior as well. I also have vertical. So if you do all 3 angles, angle, angle, angle is not a reason. Okay? You can't use angle, angle, angle. You have to have a side. Okay? So don't use angle, angle, angle. But I'm given 2 sides, so we can have several reasons. We have angle, side, angle. We have angle, angle, side. We have side, angle, side. We have any of those would be reasons, because we could show that those 2 angles are congruent by alternate interior. These 2 angles would be congruent by alternate interior. And these 2 angles would be congruent by vertical. So any combination you would like to use there, it would be fine. We'll say yes. And I'll say triangle DAJ. And so that means I'd have to say EAM. And so you pick which one you decided first. Angle, angle, side. We could have had side, angle, side. And we could have had angle, side, angle. Any of those would have worked had you picked up on those congruent angles. All right. And our last one, well, second to last one here at the bottom, page 8. Let's see, what do we have? I have an angle and 2 sides. So is angle side side or side side angle a rule? Because I don't have a shared side, I don't have parallel lines, I don't have any bisectors. I'm thinking, no, that's not a rule. So side side angle, not a reason. Moving on. Let's see. So if we are given that FH bisects, spelled wrong, bisects EHG, so that means this would be congruent to this. This is a bisector of this angle, and those two would have to be congruent by the definition of bisector. So if this were a proof, that's what you'd write down. FH also bisects EFG. So that means these two angles are congruent. So we have two angles. We need maybe a side somewhere. So is there a side that we could find in both triangles? Oh yes, this one that is shared. So we could say, oh, the shared side, FH, is congruent to itself. So angle side angle would be a reason. So we'll say yes. We'll say triangle EFH is how I'll do that one. So that means the other one would be GFH, and our reason was angle side angle. Isn't that beautiful? Okay, let's look at your assignment. So, you're going to complete the statement like we did earlier. Match up the angles and sides, and then you can write down, or you can just look at the congruency statement and write down what's congruent to what. Find each missing measure. Okay, if the two triangles are congruent, then you should be able to figure out all three angles add together to be 180, and you should be able to match up sides and figure out what the values are over here. Let's see. Next one, we're set up equations. 4, set up equations. 5 and 6, draw your triangle. Set up your equations and solve. I don't know if any of those ask you to find angles or sides, like to plug in the value of x or y in there. Then number 10 looks familiar. That's what we just did. Okay, these are establishing, before we get into proofs, it'll be establishing the reasons that you can say these triangles are congruent, yes or no, and how to recognize parts, sides, and angles. Okay, so your assignment goes through to page 10 for 16.2.